Hello dear students, the topic for today is how do we create our own custom network layers. So we are going to see custom network layers in Keras today. So in Keras you can create your own custom neural network architectures by subclassing the Keras model class. This particular approach will allow you to define your own forward pass logic. Generally what we go for is your summation wx plus b, but you can create your own forward pass logic and create highly customized network architecture. So I will just see a simple example over here. So first we are going to create our own custom layer. So whenever you want to create your own custom layer or any set of layers, what you're going to do is to create a class which is going to inherit keras.layer, and you will again implement init method in order to define your layer parameters, and you can also go for a call method to specify any different forward pass if you want. So here I am creating a class of custom layer and I am inheriting keras.layer from it, and I am using an init method wherein I am passing my number of units of that particular layer, and the type of activation function here is relu that I am using. So once I have done that, I will define the layer variables as well as weights, like whatever the parameters, weights and biases that you can go for. After that you have to define your layers forward pass logic. Here what we have used is same, that is multiplication of inputs with its weights, and then you add the bias to it. So that's our way of defining our forward pass here. So in this way you can create a custom layer. You can also create a custom model by subclassing your keras.model. So here you can also define your architecture by composing the custom layers. So here you have got class custom model, and you are subclassing keras.model in it and using init function to create here two layers. Number of units you can define. Here I've taken 64 and 10, and type of activation function also, which is relu and softmax here for an example I have taken. Moreover, again in the same way you can use a call method and define whatever you want from that particular model. Once you have finished your model, you're going to compile that particular model with respect to the type of optimizer that you can specify. Many are there like SGD, ADA, ADAM. Here I am using ADAM. Loss function you have to define, and on what metrics you want to test or evaluate this particular model. You train this particular model using a fit method and pass on the training data and validation data and suitable number of epochs, or if at all any batch sizes that you require. Then forward it up. You evaluate this particular model by passing through a test data set and checking its loss and accuracy and predicting any new data set that you have. So these are your own way of creating a custom model in Keras. Now you can also go for a model zoo. That is, when you have got a commonly used network model, basically when in CNN you have got bigger models and you don't want to recreate that models again and again, and they are very commonly used with respect to image data like ResNet and VGGNet. You do not have to manually create it, they are already built in, and you can actually implement it directly by using keras.application submodule with a line of code. So we'll see how to do it, and at the same time you can also load certain pre-trained models by setting the weights and parameters. So we are going to see one simple example of it here. You will be learning more on this when you will be working with respect to CNN. So anyways, for an example here we have used a Keras model zoo in order to load the pre-trained ResNet 50 network by using ImageNet. Okay, so here we are loading the ImageNet data, pre-trained network it is, and you are excluding your last layer. This is just an example and you can work with it. So you can see here we are loading the pre-trained ResNet 50 network with respect to ImageNet weights. Okay, and then you do not want your last layer. That's why include top is false. So little customized single line code and you are good to go with any pre-trained network, and just you get the summary. You can also define the output. Here I have used a very random normal output to test the output, but for a specific task you have to set a custom number of output nodes like 100, 10, whatever. In the attached PDF I have given you a sample code wherein you are setting 100 output nodes. So just go through that to get an idea of how you can work with certain pre-trained networks. Next is we are going to see metrics. So in Keras, you have got different metrics to evaluate the performance of your deep learning model or a machine learning model. Metrics actually provide you with a quantitative measure that will help you to assess how well a particular model is performing given a task. You can give any task like classification or regression, and you can see how well your model performs. There are a wide range of built-in metrics in Keras that you can use during your training of the model as well as during your evaluation process. So we will see what are they. So you can see n number of metrics here. The first one, if I talk, it is accuracy. So accuracy measures the proportion of correctly classified samples in classification task, if I call. It is mostly used in classification problems, by the way. The second one is precision. I hope these precision recall F1 scores, you have got an idea of it when you have learned your machine learning model, but also still precision will calculate the ratio of true positives to the sum of true and false positives. Okay, so this is again useful in classification. It is useful in situations when you have false positives very costly. Okay, when your model cannot afford false positives, then you can go for precision. Next is the recall. Recall is also called as true positive rate, by the way. It is also known as sensitivity of a particular model. It is going to measure the ratio of true positives to the sum of true positives and false negatives. Basically, it is important when you cannot miss the positive cases. Okay, next, F1 score, if I talk, it is nothing but a harmonic mean of precision and recall. Whenever you find some imbalances between the classes and you're doing a classification task, and then you want to balance your precision and recall, then you go for F1 score as your metric of your model to evaluate. And then you have got AUC ROC, that is area under the receiver operating characteristic, that we call it is a curve, and it is basically used to evaluate binary classification model, and it is going to measure model's ability and how well it can distinguish between positive and negative samples. For that reason it is going to use for that reason you will be using AUC ROC. Okay, next is MAE, that is mean absolute error. So you have seen that MAE, MSC, RMSC, all of these will be, even MAPE, they are all useful in regression task. So you can go for average absolute difference between predicted value and actual value. Then you can go for MAE. If you want to go for average square difference between predicted and actual value, go for MSC as a metric. If you want to go for square root of MSV, which is going to provide you with the same error metric as that of your target variable, then you go for RMSC. And then the last one is MAPE, which is mean absolute percentage error. So it is going to give you the average percentage difference between your predicted value and your actual value, and specifically useful in regression task. When you are working with percentage error, then you go for MAP, that is MAPE. Then you have cosine proximity. It is going to measure the cosine similarity between the predicted and actual values, and this is specifically useful in recommendation systems. And then you have kappa. Kappa is nothing but Cohen's kappa. It measures the agreement between predicted value and actual value while you are accounting for certain chance of agreement. Okay, it is useful for classification task whenever you have class distribution which is unbalanced. And then you have got top K categorical accuracy. It measures the accuracy of the top K predictions into a multi-class classification applications. It is used when you care about whether the correct class is within the top K predictions or not. So these are all the various metrics, and you are going to use them to evaluate your particular model based on the type of application that you're working with. Now we are going to see how do we create a metric container. So you can create a custom metric, especially a custom metric container. Okay, so we are going to create a custom metric container here by again using subclassing keras.metrics, and I am importing here metric and using it as my subclass. So you are going to also implement certain necessary methods that you are seeing in the code in your screen. So here I am subclassing keras.metric, and I'm adding certain weights to that particular layer and using an init method, of course. And then I use custom metric logic. You update the values in the count you calculate your own custom metric value based on whatever you want to do with that particular model. So this is the basic skeleton of the code wherein you can create your own custom metric container. And then finally you have to make sure that you calculate and return your final metric value as well. So this is the way of creating a metric container, custom metric container. Then how do we write a particular data to the metric container? Now to use your custom metric, you can instantiate it and of course update it using update underscore state method during your model training or evaluation. So you can see onto the screen during training or evaluation loop how are we using a update state method. Okay, and next is how do we read the statistical data, and if at all you want you can clear your metric container. So to read the statistical data you are going to call this method called result, and I am going to read it. So result.numpy I have called here, and if you want you can clear this matrix container by using reset states method. So these are all the different ways where you can actually customize the type of neural network layer that you want to go for. So that's it for today's class.